Hello, today we're going to work on Lesson 6, Linear and Nonlinear Functions, and this is page 12. This will unfortunately be a long lesson, so we'll probably just do page 12 today. We'll see how far we get. Yesterday we did a brief overview of what we see in equations and in tables and graphs, and now we're going to review that again today. So a linear function is a function that will make a straight line on a graph. So let's write that down. Straight line. So that's probably the easiest way to identify a function if you're given a graph. An equation is linear if it can be written in the form of y equals mx plus b, also known as slope-intercept form. So y equals mx plus b, where m is known as the slope. You could also call it the constant rate of change. We refer to it as the slope in the equation. And then b is the y-intercept, where it crosses over the y-axis on a graph. And then finally, the table is linear if it shows a constant rate of change throughout the entire table. So constant has to be the same rate of change over the entire table. So before we begin, you may have noticed that we're going to deal with exponents, and I want to talk to you about this. On the calculator, there's keys that can help us. If we have something that's raised to the second power, there's two ways we can get to that. So I'm going to just use 4 to the second power right now. So if we have 4, and I'm just going to do up the top of your page, 4 squared. We could enter this in the calculator by putting the base of 4. Then there's a special key which just says x squared. It's in the first column of your Texas Instrument calculator, and it's the 6th key down. And then if you press enter or equals, it's going to give you the answer. What this means is not 2 times 4, but 4 times 4, which is 16. There's another way you could enter this. You could enter this as the same 4 squared, but this key right above the x squared key, the 5th key down in the first column, raises it to any power. In this case, it's an exponent of 2 or a power of 2, but this key raises it to any power. So that's why this one is used so frequently. They made a special key, but this will also be very helpful. And I'd still get 16. Now, word of caution, if you have to deal with a negative number, say -5, we must enclose it in parentheses before we square it. Otherwise, the negative would be considered kind of detached from the 5. We'd square 5 and then make it negative. But now this means -5 times -5, which is going to give us a positive 25. If I wrote it like this, the calculator is going to give you it sees 5 squared and then makes it negative. It sees that negative as a separate thing. We want to kind of marry it together using parentheses, and there are parentheses keys above the 8 and 9 on the calculator. So now let's get going. This is, again, like I said, is kind of a long lesson. It's going to take us a while because it's showing us linear functions, all the same linear function in 3 different forms and how they're going to look using the same using different representations of the same thing. So if we look at this, I see an equation, and it kind of looks like slope-intercept form except for that. And if you recall from our previous lesson, if y is squared, it's not a function. So this is a function, but if it's x is squared, it's not a linear function. So we already think, based on just the equation alone, that this is not a linear equation. So now let's go to the table. We're looking for a constant rate of change, but we have to figure out what that rate of change is going on right now. So we're going to start with the equation y equals x squared. Well, we're going to put in our first x value, which is -2, so I must enclose it in parentheses and then raise it to the second power, and after that I have to add 1. So you don't necessarily need your calculator for this. If you know that that little 2 means you're going to see negative 2 times itself. Negative 2 times negative 2 would be a positive 4. And then we add 1 to that, so we're going to get 5. So now we're done with that. We go to our next x value, which is negative 1. So we're going to take that, we're going to square it, or raise it to the second power, and then we're going to add 1. Negative 1 times negative 1 is positive 1, plus 1 more will give us positive 2. If you recall, when we worked with slope-intercept form, the added number was the y-intercept, and this is going to kind of hold true for this equation. If I take 0 and square it, I'm going to get 0, and if I add 1, I'm going to have 1. So if our x value is 0, and we're working with a linear equation, y equals mx plus b, this number is where it intercepts or intersects the line, the graphed line, on the y-axis. So let's finish this up. We're going to do y equals positive 1 squared plus 1, so that would be 2, and y equals 2 squared, 2 times 2 is 4, plus 1 more, and that would be 5. So you can probably just by looking at it see that it's not a constant rate of change. It has a pattern, but not a constant rate of change. The y values, which are what we start with, from 5 to 2, the change is down 3, or negative 3. From 2 to 1, it's down 1. And from 1 to 2, it's up 1. And from 2 to 5, it's up 3. Now the x values look constant. They're just going up by 1 each time. However, negative 3 over 1 would be negative 3. Negative 1 over 1 would be negative 1. Positive 1 over 1 would be positive 1, and 3 over 1 would be positive 3. So we have a pattern, but not constant. It's not constant rate of change the entire table. So that's nonlinear. So we're guessing that this graph is not going to be a straight line either. We're going to start with the ordered pairs. The first x value is negative 2, and it's paired with 5. So we're going to count over negative 2 from the origin, and then go up 5 and put a point. The next ordered pair is negative 1 and 2. So I'm going to go over 1 and up 2 and put a point. We now have 0 and 1. Well, we talked about this. This is going to land right on the y-axis, a y-intercept. So just like a linear equation that happened again when 0, whatever the x value is with 0, or y value is with 0, is a y-intercept. Then we have 1, 2, so positive 1 and up 2. And we have 2 and 5, so positive 2 and positive 5. So you may recognize this shape. Excuse me, you might have talked about this with in the last unit. This shape is called a parabola, and it is a function because it would pass a vertical line test, but it is not linear. So it says, is this function linear? And that answer is no. However, there are a myriad of reasons you could get. I'm just going to write nonlinear. You could base your reasoning, excuse me, on the equation, or you could base your reasoning on the table or the graph. So any of them and all of them let us know it's nonlinear. So let's look at number 2. Based on the equation, it said it has to be in slope-intercept form. Do you think this is in slope-intercept form? Well, maybe, or maybe yes, maybe no, so we'll discuss that later. Let's move on and see if we get a constant rate of change in this table. And so what would happen is we would take y equals 1/2 times x. In this case, first one's negative 4. And by the way, multiplying by 1/2 is the same as dividing by 2. So that would be -2. Y equals 1/2 times -2. Well, -2 divided by 2 would be -1. 1/2 times 0 would be 0. Half of nothing is nothing. 1/2 of 2 would be 1, and 1/2 of 4 would also be 2. So we're seeing a very similar pattern. Okay, let's see if this is constant. So I'm going up 1, up 1, up 1, up 1. So the change for the y values is consistent throughout the table. The change in the x's is up 2, up 2, up 2, up 2. So if I wrote my change in y, which I do have a constant, my change in y value is 1, and my change in x values was 2, and we've seen this someplace before. That is our slope. We also do have a y-intercept right here, and it's paired with 0. So if I graph that, it'd be right here. And so guess what? This equation might not have looked like slope-intercept form, but if we include, we would add 0 to it. We're in good shape. It is still going to make a straight line. The equation now is in slope-intercept form. Even without the 0, it's considered that. And now we're going to graph it to prove it. So we're going to go back 4 for the x. So we're doing this ordered pair, by the way. And we're going to go down 2 and make our first point. For this next ordered pair, we have -2, -1. So we go -2 and -1. Yep, these points line up so far. We already have 0, 0. Now we're going to go 2 and 1. So we go over 2 and up 1, still lining up. And then over 4 and up 2, over 4 and up 2. Sure enough, this makes a line. So this is a linear equation. And again, you can say any one of those reasons or all of those reasons. So this is linear. So it says, what do you notice is different about the functions in question 1 and 2? Well, I want you to write what you notice that's different, and there are many things to choose from. You can write all of them or just a few of them, and just noticed a little error there. Have to correct that. So thank you for listening. Have a great day, and we'll do the next page tomorrow.